Hello everyone, welcome to the lecture series on computer architecture and organization. This is a lecture 7. In this we are going to see about input output devices. So input devices. First is keyboard. A keyboard has its own processor and circuitry that carries information to and from that processor. A large part of the circuitry makes up the key matrix, which is arranged in rows and columns. The key matrix is a grid of circuits underneath the keys. In all keyboards, each circuit is broken at a point below each key. When a key is pressed, it presses a switch, completing the circuit and allowing a tiny amount of current to flow through. The mechanical action of the switch causes a vibration called the bounce, which the processor filters out. If the key is pressed and held continuously, the processor recognizes it as the equivalent of pressing a key repeatedly. Another type of keyboard has three layers. The top plasticide layer with key positions marked on the top surface and conducting traces on another side. Middle layer made of rubber with hole for key positions. Bottom metallic layer with raised bumps for key positions. So this figure illustrates this. When a key is pressed, the trace underneath the top layer comes in contact with the bump in the last layer, thus completing an electrical circuit. The current flow is sensed by the microcontroller. Mouse. A computer mouse is a handheld pointing device that detects two-dimensional motion relative to a surface. This motion is typically translated into the motion of a pointer on a display, which allows a smooth control of the graphical user interface. There are two kinds of mice, rolling grabbable mouse or optical mouse. As the mouse is moved, the ball rolls under its own weight and pushes against two plastic rollers linked to thin wheels. One of the wheels detects movement in an up and down direction, that is y-axis, and other detects side to side movements, that is x-axis. If the mouse is moved straight up, only the y-axis wheel turns. If the mouse is moved to the right, only the x-axis wheel turns. The optical mouse shines a bright light down onto the desk from an LED mounted on the bottom of the mouse. The light bounces straight back up off the desk into a photocell, also mounted under the mouse, a short distance from the LED. The photocell has a lens in front of it that magnifies the reflected light so the mouse can respond more precisely to your hand movements. As the mouse is pushed, the pattern of reflected light changes, and the chip inside the mouse uses this to figure out the motion. Trackball, joystick, and touchpad. A trackball can also be used as an alternative to a mouse. This device also has buttons similar to those on a mouse. It holds a large moving ball on the top. The body of the trackball is not moved, the ball is rolled with fingers. The position of the cursor on the screen is controlled by rotating the ball. The main benefit of the trackball over a mouse is that it takes less space to move. The trackball is often included in laptop computers. Standard desktop computer also uses a trackball operated as a separate input device. A touchpad is a small plain surface over which the user moves his finger. The user controls the movement of the cursor on the screen by moving his fingers on the touchpad. It is also known as a trackpad. A touchpad also has one or more buttons near it. These buttons work like mouse buttons. Touchpads are commonly used with notebook computers. A joystick consists of a base and a stick. The stick can be moved in several directions to shift an object anywhere on the computer screen. A joystick can perform a similar function to a mouse or trackball. It is often considered less comfortable and efficient. The most common use of a joystick is for playing computer games. Scanners. Scanners operate by shining light at the object or document being digitized and directing the reflected light onto a photosensitive element. In most scanners, the sensing medium is an electronic light sensing integrated circuit known as a charge coupled device. Light sensitive photosites are arrayed along the CCD converts levels of brightness into electronic signals that are then processed into a digital image. The scanner consists of a flat transparent glass bed under the CCD sensors. Lamp, lenses, filters, and also mirrors are fixed. The document has to be placed on the glass bed. There will also be a cover to close the scanner. The lamp brightens up the text to be scanned. Most scanners use a cold cathode fluorescent lamp. A stepper motor under the scanner moves the scanner head from one end to the other. The movement will be slow and is controlled by a belt. The scanner head consists of the mirrors, lens, CCD sensors, and also the filter. The scan head moves parallel to the glass bed and that too in a constant path. As the scan head moves under the glass bed, the light from the lamp hits the document and is reflected back with the help of mirrors angled to one another. According to the design of the device, there may be either two-way mirrors or three-way mirrors. The mirrors will be angled in such a way that the reflected image will be hitting a smaller surface. In the end, the image will reach a lens which passes it through a filter and causes the image to be focused on CCD sensors. The CCD sensors convert the light to electrical signals according to its intensity. The electrical signals will be converted into image format inside a computer. Output devices. The CRT monitors were fundamental output delay or display device. The CRT or the cathode ray tube is the picture tube of a monitor. The back of the tube has a negatively charged cathode. The electron gun shoots electrons down the tube and onto a charged screen. The screen is coated with a pattern of dots using phosphor that glow when struck by the electron stream. The image on the monitor screen is usually made up from at least tens of thousands of such tiny dots glowing on command from the computer. The closer together the pixels are, the sharper the image on screen. The distance between the pixels on a computer monitor screen is called its dot pitch and is measured in millimeters. Most monitors have a dot pitch of 0.28 mm or less. There are two electromagnets around the collar of the tube which deflect the electron beam. The beam scans across the top of the monitor from left to right, is then blank and moved back to the left hand side slightly below the previous trace on the next scan line, scans across the second line, and so on until the bottom right of the screen is reached. The beam is again blanked and moved back to the top left to start again. This process draws a complete picture, typically 50 to 100 times a second. The number of times at 1 second that the electron gun redraws the entire image is called the refresh rate and is measured in Hz. It is common, particularly in lower priced equipment, for all the odd numbered lines of an image to be traced and then all the even numbered lines. The circuitry of such an interlaced display need to be have only half the speed of the non-interlaced display. An interlaced display, particularly at a relatively low refresh rate, can appear to some observers to flickers and may cause eye strain and nausea. The intensity or strength of an electron beam is controlled by setting the voltage levels. The number of electrons that hits the screen determines the light emitted by the screen. When the voltage is varied in the electron gun, the brightness of the display also varies. The focusing hardware focuses the beam at all the positions on the screen. The deflection of electron beam is controlled by electric or magnetic fields. So two pairs of coils mounted on the CRT to produce the necessary deflection. The coils are placed in such a way that magnetic field produced by them results in transverse deflection force that is perpendicular to the magnetic field and electron beam. An LED screen is an LCD screen, but instead of having a normal CCFL backlight, it uses light emitting diodes as a source of light behind the screen. An LED is more energy efficient and a lot smaller than a CCFL, enabling a thinner television screen. Printers. A printer is an electromechanical device which converts the text and graphical documents from electronic form to the physical form. They are the external peripheral devices which are connected with the computers or laptops through a cable or wirelessly to receive input data and print them on the papers. Quality of printers is identified by its features like color quality, speed of printing, resolution, etc. Modern printers come with multi-purpose functions, that is, they are a combination of printer, scanner, photocopier, fax, etc. Broadly, printers are categorized as impact and non impact printers. So that's all about input and output devices. Thank you.